Thank you and welcome. The sort of struggling, when I was putting this presentation together, it was sort of a little bit of a Goldilocks moment. It's like, okay, how technical do I want to get? I mean, it's sort of media and entertainment could have, either a lot of, the classic Hollywood types, or we're going to have a lot of IT people. So hopefully what you find here is a little bit of a Goldilocks sort of presentation, a little bit for everybody. As I said, so I'm the VP of products for PBS, and what products means to me, I grew up at AWS, but the formative part of my career at America Online back on the East Coast. And so for me, product development really encompasses sort of an integrated organization. So I've got engineering, I've got QA, I've got visual design, and I've got product management. And in my case, unlike how we ran things at AOL, I actually have ops. And so at AOL, operations was a very formidable, very impressive thing. And we sort of developed these products and then threw them over the wall, and the operations guys sort of ran it. And today we are living in a very different world. And the story I'm going to tell you about PBS, I think, is sort of a perfect case in point for why that is, and how how sort of great story for sort of, I guess, the story of DevOps, and really how the cloud computing has really sort of changed how we approach some of these problems as product developers. So first, a little bit about PBS, because I think PBS means a lot of things to different people. I grew, as many of you did, I sort of grew up with PBS. My dad made me watch the McNeil-Lehrer NewsHour, and to this day I won't watch it as a result of that. But PBS sort of represents a lot of sort of iconic brands that we're all familiar with at some level, sort of Nova, Masterpiece, Frontline. The McNeil-Lehrer NewsHour, now known as just sort of PBS NewsHour, all sort of people sort of know and love, not to mention all the kids brands like Sesame Street and Mr. Rogers and so on. So a little bit more about PBS. There's three main business units of sort of PBS. There's sort of the general audience side, which is where I do most of my team is sort of focused on. There's also PBS Kids, which sort of builds the applications and produces the content that, for those of you with kids, they probably consume every day. And there's PBS Education, which does content and tools for members of sort of the educational community. Point number two. I can't tell you how many times I've been at a party and people say, well, so where do you work? I say, I work PBS. She goes, I listen to you every day on the way into work. We are not public radio. We do TV. Having said that, we're sister organizations with NPR, and there's a lot of similarities. We're exactly the same, except for the fact that we're a TV and they're a radio, I guess. So we are, unlike many other sort of businesses in this town, or sort of in the media industry, we're a member organization. So we have 165 dues-paying stations. What this means is stations own us and not the other way around. And so that creates an interesting sort of power dynamic. They pay membership dues to us, and we turn around and use those dues to commission and license broadcast and digital content, as well as build the distribution infrastructure, whether it be sort of satellite distribution network for the broadcast side, or in the case of my particular group, all of the distribution infrastructure for interactive, the websites, and so on and so forth. Another sort of peculiarity of PBS is producers are definitely not owned by PBS. However, it's a little more complicated than that. They're not all independent. So about, I'd say, a good chunk of them are actually sponsored or owned by the stations. And then there's quite a number, Children's Television Workshop being a good case in point, that are independent. Independent Lens, POV, a couple other reasonably well-known brands. So this creates all sorts of unusual conflicts of interest. So like WGBH is one of the largest producing stations within the PBS ecosystem. So they pay us dues to turn around and buy their content from them. So we often get into discussions where we have to sort of remember what hat it is everybody is wearing. So PBS is #1 in unique visitors amongst all of the major networks. And I think people are generally surprised to sort of see that. A good chunk of that, obviously, is kids. So even if you take out the kids, we're still on #4 within sort of the unique visitor rankings. Some more fun numbers, you know, and these may be not big by social media standards, but certainly big, or social application standards, but certainly big within our industry. So we have over 1 million Facebook fans at the moment. We do about 18 million unique visitors a month, 37 million visits. You know, pushing 400 million page views on a monthly basis. We do about 93 million video streams. And an interesting statistic, I've spoken at a lot of sort of mobile conferences, as you might expect, in the last year. And people often say, well, how much of your content is online? And the number I hear people saying is sort of being successful and sort of indicative of sort of where we are generally is, you know, 10% seems to be the norm. And we launched our mobile apps a little bit less than a year ago, and we're already at 27% of hours watched sort of in the interactive medium are now coming from mobile. And so to me, this is sort of a very, it's a very telling statistic for how quickly we've been able to reach our audience in some of these new spaces. So now is sort of the Amazon part of the story. So for me, there's sort of life before Amazon, and there's sort of life with Amazon. So I came to PBS 3 years ago, and it was a very, very different place. We were sort of a traditional, you know, big iron, in quotes anyway, infrastructure organization. The PBS sort of IT department, you know, a small department of folks sort of managed all of our, you know, ping, power, and pipe, as we sort of referred to it at AOL. You know, keeping the blinking lights working on the servers, but everything from Apache on up really was up to the, you know, the predecessors in my group. There was no real disaster recovery, and we had sort of fixed bandwidth. We're also operating in a sort of a shared hosting environment. So there was the original web architecture that had been launched maybe 10 years before that, very traditional sort of 3-tier architecture. There we had roughly 1,200 hosted websites, essentially, and a number of small applications which had been developed over this period of time. And there was very little isolation between them. So some producers would do something, and as a result, it would ripple through the entire stack and bring everybody down. And as a result, we had to create this system of rules which dictated how much people could do, and that really stifled the ability to innovate. On top of that, we had no real product development capability, again, by that definition that I led off the discussion with. We had a small team of essentially webmasters who had, you know, come out of principally, you know, design build firms. Projects were typically built on the outside by design build firms still. Websites or maybe small applications, they were thrown over the wall. We put them on our servers, and they sort of ran. But there was no sense of managing that product life cycle for how do we remain competitive in the marketplace, not just with respect to content anymore, but with respect to the services that we provide. And certainly, we weren't building services in the classic web services standpoint, and so there was really none of that. As a result of all this, life was actually fairly painful when I arrived. We had routine outages, lots of downtime. We had lots of, you know, multiple single points of failure, and as a result, we were in a perpetual state of emergency. As I mentioned, we had no isolation between producers or the applications. So one very sort of can-do enterprising producer uploads a script that does this one particular thing with this content. They chew up all the CPU, and before you know it, the whole PBS website is down. That was just sort of a fact of life back then. And as was sort of the previous speaker had sort of spoke of, adding new hardware was sort of like, you know, it reminded me of life at AOL, where you had to order it, and they had to bring it in, they had to provision it, they had to build it, they had to install it. And so this was in a very long, arduous road that I certainly did not look forward to. There was very little long-term product planning, and as a result, for the few web technologists that were in my organization, very poor morale because everybody hated us. The producers hated us, the stations hated us, we were down, and we weren't getting any products built. Our stakeholders were generally very, had very little confidence that we could actually deliver anything. So fast forward now 2 years, and life is a very, very different it's a very, very different place. Life is very different. All new applications and all new producer sites are now being put on EC2 today. So what started off largely as an experiment about 2 years ago was sort of gained steam, and we still have a lot of what we call sort of legacy infrastructure that's managed internally, but those are all just sort of some of the older producer sites that we haven't yet migrated. We will be probably migrating the rest of those over the course of the coming year. So as we sort of break it in, there's a couple of, and I'll get into a couple of these use cases in a little bit more depth here in a moment, but a couple of different things that we're doing. Certainly, we're hosting a large number of producer sites. We have the PBS.org national portal running here. We have our whole video distribution platform now operating on EC2. Our registration and profiling system, which has been built out relatively recently. Sort of a next-generation template and publishing system for sort of that long tail of producer sites that we've accumulated over the years that don't necessarily have high traffic, and we want to keep production costs down on. TV schedules, which is a very, very important service for the entire community, and a wide variety of other tools. All of our admin tools, all the applications for PBS education and kids are moving over there as well. And last but not least, for me as a product development organization, all of our development staging QA environments are all hosted out there too. So, and by the way, if anybody has any questions, feel free to interrupt me, or you can sort of save them until the end. So, on my way out here, I hadn't looked at this in a while, and I sort of said, well, how much we really have running out there. And I'll get into a little bit more of this, but it's in many ways it's been so easy. We've had what I would sort of starting to refer to as infrastructure proliferation. Keep in mind, in our legacy infrastructure, we had probably, I don't know, let's say 20 some odd Blade, HP Blade servers running in our network, and now we have hundreds of actually 270 EC2 machines. We have 75 load balancer instances, quite a few elastic IPs. It's all spread across 5 different AWS accounts, 52 of the host or the MySQL as a service RDS databases. And the one that sort of struck me is, 608 EBS volumes, which actually exceeds the number of servers that we've got. And so I actually discovered a problem with how we're managing some things internally as I sort of prepared for this. And we've got more S3 buckets than I could count. And we have 19 different CloudFront distributions in there. So a little bit about our technology stack. We're a fairly traditional open source, house. So everything we have running, with the exception of maybe one machine, is on Linux CentOS 5.2. We had been, internally we'd all been Red Hat Enterprise Linux, and this was something that was very close and we were sort of very familiar with. We're predominantly Python Django as a development environment with a little bit of Perl and PHP thrown in, more a function of some of our older legacy systems. All Apache web server databases are almost exclusively MySQL, sort of predominantly RDS, and a little bit of hosted MySQL we have running on some of the producer sites. We've played around a little bit with a simple DB. Caching, predominantly Memcached. We host it. We haven't yet moved to Elasticache. We use Solr a little bit for that. File storage, sort of a mix between S3 and EBS. Job management, predominantly Celery, hosted Celery that we do, which is something for sort of the Python community. We've played around with SQS a little bit. Transcoding, although there isn't really a corollary Amazon service yet today, I don't believe, but I'll talk a little bit more about this later. Zencoder we use for a lot of our sort of at least cloud-based transcoding needs. And then a very, very big piece of our solution in making this all work for us is that we use a company offering from Rightscale, really as sort of a managed, sort of a service management layer sitting on top of that. So a little bit more about Rightscale. So we use them to manage all 5 of these accounts. We have, probably 30 employees that have access to various bits and pieces of these accounts and sort of do different things. And so Rightscale really provides that authentication and authorization layer that we need to sort of make this work. When we started down this road, the Amazon Management Console didn't exist, so Rightscale really was a very important piece. We wouldn't have started this without them. They also provide sort of a uniform sort of performance monitoring and alerting framework for us based on CollectD. And probably most importantly is that they provide a configuration management platform. So we really have 5 shared templates that we share across these accounts that sort of meet all of our needs, so we can do upgrades across all of these machines pretty easily. And they make it easier for us to provision most of the AWS services, although not all. So now I'll sort of talk a little bit about, I guess, some of the actual use cases, and I could actually spend 2 or 3 hours talking about this. So I've sort of tried to pick 2 that are more illustrative of the different ways that we've used Amazon and Rightscale and so on to solve some of our problems that are hopefully relevant to you. So the first one, and sort of the problem that I led off with, is we're using it to host producer sites. And again, some of those iconic brands that I mentioned earlier. And we're doing this in a fairly traditional way, although not with tools, that you might see from a standard sort of, let's say, slice hosting service. We really run this as a dedicated VPS-style hosting. So we will give a particular producer, we will give them their own machine, and they will give them shell access into it. And it'll be based on one of our sort of standard integrated LAMP templates. Most of these are smalls. Whenever they try to do something on Drupal, they always end up needing a much larger machine. The thing about, sort of a lot of these producers have, as I sort of mentioned earlier in the discussion, the producers were upset with PBS. We were getting in their way. We were limiting their ability to innovate. And they were saying, I want to use this tool because this is going to help me reach my audience. And, it's like at some point we had to say, okay, fine. You want the freedom to innovate. I'll give you the keys to the Porsche. But the problem is, if you wreck the Porsche, you've got to fix it. And so that's essentially what we've done. We've given them an instance, and we've given them shell access, and they can do almost anything on that, and they really can mess it up. And we've seen it in a couple of cases. But unlike the previous life, where when they did something foolish, they brought everybody else down with them, now they just sort of bring down their own service, and everybody's generally happier. So we offer a sort of VPS-style SLA. We'll reboot the machine for them and provision a new one based on sort of previous backups, of which we sort of do nightly backups. But most importantly, we do now have them all isolated, and they have that freedom to innovate. And so they're starting to charge forward. So that's sort of one use case. The second really big use case, and this is really, I think, the cornerstone and sort of the crown jewel of PBS, is our video distribution system that we've built. And this video distribution system, which didn't exist 3 years ago, or was actually just being built when I came to PBS, is now powering quite a number of products. My favorite is sort of the PBS Video for iPad, where I think at any given time you can get probably 250 relatively recently broadcast hours of PBS content is available. This launched back in November of 2010. Earlier this year we won a Webby Award, and on a couple of different occasions we've actually been #1, I believe, in the entertainment category within iTunes. A second application, but is focused for PBS, or focused on the kids' audience, but built on the same, not only iOS code base largely, but also the same distribution infrastructure instead of APIs, is the PBS video app for kids. Also launched with great success. And last in that sort of category is we also have a video app that we launched back in January for the iPhone. So that's sort of it on the mobile side. And then we also launched, and this is sort of the project that was in flight when I came to PBS, is we have a local national, or a video portal platform. So we have the national portal that's available at video.pbs.org, but each station also has the ability to have their own basically white label experience where they can pick and choose the national content or other station content that they want to appear on it, as well as it's a platform for their own locally produced, local market station content that they want to make available on their own particular domain. So underlying all of this is this video distribution platform that we've built. So there was the platform that was in flight several years ago when I came had been built by an outside design build firm, was thrown over the wall, and we sort of had to jury rig it, and it had not been built with the cloud in mind, let's to say the least. So over the course of the last couple of years, we've fundamentally re-architected it and rebuilt it. And so so this really is what it's going to be like when we launch here in the next week or two. So starting with sort of the one end of the stack, from the CDN perspective, we utilize two CDNs. Today we use Limelight for all the static HTTP content, for static images, GIFs, JPEGs, and so on. And then we use CloudFront for 95+% of our streaming content, principally RTMP, but also the pseudo-streaming material that we are providing to our mobile clients, which technically is still HTTP. Yep. The reason, well, actually, Mark, the opening speaker, sort of alluded to it. About a year and a half ago, we were almost exclusively on Limelight, and we were having quite a number of issues where content wouldn't be available, or end users were reporting streaming errors. And we looked at some instrumenting tools to sort of let us know where this was happening. Limelight wasn't able to tell us. And so we ended up having to write our own, and also I wanted to move to a dual vendor sort of environment where I didn't have, not only didn't I have lock-in, but I also had some ability to shift to a different vendor in case there was sort of operational issues, and not to mention sort of costs. We were sort of in this very traditional, renegotiate every year, with Limelight, and they pretend that their service is not a commodity, and I tell them that is. And the best way to prove to them that it is a commodity service is, I come over here and I try out CloudFront, and it's better performance, and it costs about, at least at that point, a fifth of what Limelight was trying to tell me their service was worth. So we sort of did that, and since then the performance has been so good and the costs are such that I've moved almost all of our content now over to CloudFront on the streaming side, and it's just a little more of a hassle to move the static stuff, but that'll probably eventually move as well. And as he mentioned earlier, we're pushing well over a petabyte a month. I think actually coming close to a petabyte and a half. So the rest of the presentation layer, so in this particular case, we'll have a manually scaled array of 4 medium service. Again, we're using sort of arrays in the Rightscale sense, all load balanced by ELBs, and all of the the application template is pulled out of S3 where it's stored. Caching layer is all hosted memcache. That will eventually move that over to Elasticache. Just haven't really made it a priority. But certainly, Elasticache will do for us what RDS did for us on the database side. In terms of, we tend not to have a lot of issues with our hosted memcache, but still, sharding has been a problem a little bit for us with memcache in a hosted sense. Sort of working our way down, sort of the service layer, the REST API, again, manually scaled array, ELB load balancing, S3 application server templates out of Rightscale, and last, the data layer is now all exclusively RDS, sort of master slave operated out of RDS. For load balancing here, though, we use HA proxy. Because ELBs are sitting basically outside the firewalls, and we don't want to expose port 3306 to people out in the general network. So we need to have the load balancer be part of a security group and lock down access. So the third piece is sort of the interesting thing that we sort of are moving, and this is a story that's maybe half written, is sort of the video transcoding service. So we are currently today really transcoding just for one endpoint, and we're sort of ingesting, by our sort of definition of mezzanine quality, about a 5 megabit files, and our only current output today is Apple's HTTP live streaming for iOS distribution. However, once we put the finishing touches on this service, we'll actually start outputting our web output as well as outputs for our various partners like iTunes, Amazon, and so on. Today, these other outputs are actually coming out of our internal sort of big iron media operations center, where they've got Radiant Grid clusters running. Essentially, all we've done here is we put an API configuration wrapper around Zencoder. And so it avoids, it gives us the abstraction, avoids, vendor lock-in, and we can ultimately put in other transcoding solutions if we were ever to get to a point where we were unhappy or found their sort of solution to be insufficient. All of our file storage is in S3, and again, as I mentioned earlier, all of the distribution happens via sort of the CloudFront CDN. A little bit more about Zencoder. When we were launching Zencoder is not the service that we actually launched with when we launched our mobile applications. So probably, we're a bunch of engineers, and of course we say, well, this would be fun. I mean, FFmpeg is fun. I can build this myself. This really isn't that hard. And tried it, and certainly HTTP live streaming was enough of an emerging standard and, was not incredibly well documented, and we had a lot of issues with it given all of our long-form content, and very quickly gave up the homegrown solution and started looking at sort of SaaS-based options out there, and started with one service, whose name I won't mention, and had a lot of problems with it. They didn't work well with S3. They certainly didn't understand, I think, the HTTP live streaming formats and protocols very well, and we had a lot of quality issues, and ultimately settled on Zencoder, which as you know from earlier discussions, is also hosted in the Amazon infrastructure. They gave us a very, very good API. Very important for us of fast encoding times. I mean, with the previous service, we had PBS NewsHour episodes. We were getting their ingest file at about 9 or 10 o'clock in the evening, and sometimes we wouldn't get it up till 24 to 48 hours after that in the mobile formats, which, frankly, isn't that hot when you're talking about a very timely news show. And so today we have that down to under an hour from when we get it to the point where it's ultimately up and available in our mobile distribution channels. So that was big. It's still based on FFmpeg, so that it's something that we still know, and it's not so out there that if we had to go alternative routes, it would be something that would be at least be conceivable. They had very strong support for Apple's iOS, a strong understanding of the formats and some of the nuances and the pitfalls of dealing with it. And probably, as it turns out, you'd think it wouldn't have been that hard, but they had offered very reliable support for Amazon's S3 storage. Now, for those of you that are familiar with the Apple format, you take a mezzanine file and you first of all you downsample it to 3 or 4 or 5, in the case of the iPad, different quality streams, and then you chop those encoded streams up into little 10-second bits. So ultimately, we're talking about, for a 2-hour episode, we may be pushing 2,000, 3,000, 4,000 files out to the network. And when one of those fails, the whole thing goes bad. That was a problem with our previous vendor, and certainly that has not been ever an issue with Zencoder. And last but not least, and this is sort of certainly isn't sexy for management or for anybody outside, but as a product development guy, this was big for me. The bane of our existence as developers has always been, you develop something in development, works great, and then you push it out into production and it doesn't work so well, and it's like, well, you had a difference between development and production. And so we've been able to, with the combination of Rightscale and Amazon, truly create a set of sort of mirrored environments and topologies. Not, obviously we don't need quite as many machines, but we can duplicate those pieces of the stack that we feel are important and introduce sort of issues with sort of quality and reliability. We use this for load testing, we use it for demos and training, and we're moving to a world where it can be on demand so that I don't have to leave this infrastructure up and running all the time. I spin it up when I need it for QA, and I automatically spin it down. So last slide, and then we can sort of move on to sort of the next speaker. Sort of the takeaways for me, and sort of leave with you, sort of lessons learned, in no particular order, but vastly improved uptime. When I came, I mentioned all those single points of failure in our previous stack. We still have a long way to go, but we are already, and I just did a report to our board a couple of weeks ago, we're already easily at 3 nines, in fact, probably approaching 4 nines. And this is better than I actually ever anticipated being able to get to. And when I arrived, maybe we got 2, and some weeks we only got 1 9, and that really wasn't very good. We've also moved from an era where infrastructure was an obstacle. It's like I can't provision the hardware fast enough to get my applications on it, or I have to spend a lot of time trying to debug something, the configuration got all squirrely, and I've got an investment in this piece of big iron. I got to go in there and figure it out, and now I can put a bullet in it, and I just start over, and I don't have to waste any time. So it's really, I've removed it as an obstacle, and now it's sort of an asset to me. And third, and this is something that but actually a year and a half ago, I actually attended a Rightscale event up in New York, and the Amazon CTO spoke about it, and I'm sure all you Amazon guys have sort of heard this speech many times, but he talked about designing for failure, and I really took that to heart, and we've tried to institutionalize that within PBS, and we now build all of our applications with the cloud, Amazon, and Rightscale in mind. And so we've built it for failure so that if it goes down in the middle of the night, a monkey can restart it. And sometimes that monkey may be me because I may be the only one checking email, or it may be anyone else sort of in the staff, and they don't have to have a lot of familiarity with the application. They can clone it and restart it, and it comes back up with a minimal to no loss of data. And for us, that's huge. And we've really been able to, I think, it sort of speaks again to the SLAs or the service levels that we've been able to achieve. The one downside, and I alluded to this a couple times, is easy can become expensive. And so we've now removed infrastructure so much as an obstacle that, I was talking to my head of operations the other day, and he sort of was commenting. He came out of the ad network, ad server world, and he said, it's now so easy. Somebody wants a server, they just send him a ticket and they spin one up and it's there. But then they move on to their next project, and the end of the story isn't, it's like, oh, you can shut that down now. So we just get this sort of natural proliferation in assets, sort of like the federal budget. And so we have a case of proliferating infrastructure. And so now the pendulum has swung far enough for us that it's going to be worthwhile, or it's currently worthwhile for us we now want to invest in probably a little bit of efficiency. How can we move to a little bit more of a, not completely, but a little bit more of a shared hosting environment in some cases? How can we make sure that those dev, QA, staging, load testing environments are shut down the minute they're no longer used, and then brought up the minute that they're needed? So with that, I leave you with, Amazon, this has really been a fun sort of story for me to sort of go back through and think about. I played with the early Amazon APIs. I guess it would have been in 2006 as they were sort of coming out with EC2 and S3, and really couldn't have used them at PBS back then. But the tools have come so far, and the partners that sort of support them have come so far. It have really, I think, been a huge part in the success, and I think some of the things that we've been able to accomplish at PBS. So with that, I guess I open it up for questions. Yep. Yes. Yes. So the question was, what video player are we using, and what are we using sort of for analytics? So that hit the high points of that. So we are today using a company called The Platform, which is a company owned by Comcast. And if you sort of think back to where we were, 3 years ago, and this is part of our first generation platform. So we use The Platform essentially as our digital asset management and sort of video CMS. And so we use their the platform's PDK, the professional development or player development kit, as the basis for ours. However, we are moving away from that, and we are going to move to, I think it's OSMF, the open source media framework player will be, and we're also going to be, we essentially have duplicated most of the capabilities of the platform that we needed in this sort of next-gen architecture that we've built out. So we are, over the course of the next year, going to be moving away from that. For analytics, there's sort of the traditional sort of web analytics that, we've used visible measures and now mostly use, at least for video, Google Analytics, some of their video offering. We've looked at, a couple of others, haven't been terribly happy with. Our ecosystem makes some of this fairly complicated. From the standpoint of the quality measures piece, though, which I sense may be part of the question I alluded to earlier in terms of CDN quality, we looked at a commercial offering. It was very, very expensive, and we ended up just instrumenting the player ourselves using sort of standard Adobe Flash error messages. And then in terms of the data crunching and visualization framework, we've actually built a tremendous amount of it on a product called Splunk, which is, as you know, a sort of log file analysis tool that is very, very powerful and allows us to have a sort of very good view across all of our infrastructure. Other questions? Yeah.
You didn't mention anything about DRM and packaging and wrapping. Are you using Zencoder for wrapping after your transfer?
So the question was, I didn't mention anything about DRM, and you're exactly right. We really don't have any DRM today in place. Well, with mobile and with our sort of web distribution infrastructure, it's all just streaming. People can't play it back. Yes, we've made it sufficiently hard that your average user can't sort of steal the content and so on. And it's sufficiently easy that you can buy things relatively cheaply on iTunes or Netflix or so on. That that's where we've sought to strike that balance. As we move to the Android platform, however, where they don't, we will probably be needing to adopt some of the DRM because we don't want the Flash-based playback experiences aren't of sufficient quality there that we may need to offer a progressive download, which will require in that particular case. And also, users have much more open access to the file system on the Android, so we will need to look at something that's DRM-based. And we haven't done any investigation yet, so I don't know whether or not we'll use Zencoder or not. Any other questions? Over here?
Your monitoring infrastructure, do you keep that in the cloud or is that on real hardware?
Wasn't the cloud real hardware? That's what they told me. It is all in the cloud. So we have actually our sort of the data crunching and every one of our machines has a Splunk agent running on it. And that sends the data back to the Splunk receiver, which is running on, I believe, an extra large at the moment. And it's a Java app, so yes, it's a memory and CPU pig, but it's been sufficient to sort of give us, whatever. And we've built out quite a number of dashboards for visualization and, understanding sort of the data streams and monitoring the health of all of our systems. That's worked very well. Yes.
Considered billing back to producers and then having them kind of monitor their usage through hours.
Yes, and if I were lucky enough, I don't know if you remember the numbers from that slide, or maybe actually I may have taken the actual numbers off. I had a breakdown of which of the sort of use cases had how many servers. Now, the reality is the producers are not the big problem. It's my own developers. So the producers currently, we have, I think, 43 producer machines. And if you remember the total, it was like 260 or 270 machines in total. Most of the issue is my team. It's just like, wow, it's so easy. I'll just spin up a new one rather than, repurpose an existing one, or, they forget about it and the closet grows full. So billing back is the least of an issue. We're starting to put in place where no longer can they just open a ticket to say, give me a machine? Now we are starting to put in place some reasonable sort of cost benefit and, say, how long do you, it's a finite duration, how long do you want this to run? And at the end of that time period, we will shut it off. Yes?
You mentioned that on the slide that you do Bamboo-based continuous integration.
Mm-hmm.
I assume that the dev servers are on AWS.
Yes.
So how do you do keys management and have that real time still be able to successfully integrate that onto the server?
You've now exceeded my pay grade. The question is, I think how we do sort of key management with Bamboo, and I have absolutely no bloody idea. But fortunately, somebody on my team does. We have, a number of we have, I think, 4 or 5 Bamboo-related machines that are running that, and I don't know how they are. I've heard them discuss a couple times, but if you're very interested, and just give me your name, I can put you in touch with one of our developers, and they can tell you. Yes. Oh, yes. I'm actually glad you brought that up. So with our first generation video platform, it was built by a design build firm up in New York. Unfortunately, we chose them more for design and probably less based on the quality of their build capabilities. And so they built us an application, again, not with the cloud in mind, and we've adapted it as best we could to the cloud. But it's an application that is incredibly inefficient. Each medium, Amazon EC2 instance, can handle two requests per second. Keep in mind that all the really hard work is being done by the edge on the CDN. And so, so what we use to do that is we put in place auto-scaling arrays in Rightscale, and we have that instrumented to, I think, Apache load, so that when load gets up to a certain level, then it provisions new machines. That takes about 10 minutes to bring online because a lot of the machines are dynamically configured, again using Write scripts and sort of the Rightscale platform. So that will scale from a minimum of about I think 12 or 14 machines in the wee hours of the morning up to, I've seen it go as high as 30. Depending on what sort of, during a big broadcast event like, Masterpiece on a Sunday night. So with the new architecture, and we're anticipating it'll probably take all of maybe 4 or 5 machines. So it was just a very inefficient, highly coupled. I mean, they violated every good developer rule. Yes?
Another quick question another quick question in terms of like backup and redundancy and availability zones. Can you just maybe give us a quick overview of like your strategy as to like maybe how to avoid getting hit by the last situation that happened with the bridge?
So frankly, that's it's not a. We chose Amazon. We know that we have a lot of options to do that. We haven't invested a lot of time thinking about DR, just because uptime at Amazon has been so much better than the world I sort of came from, or what it was like when I arrived. Having said that, in the last month or so, we've been talking about what it is that we're going to do. Generally, I think almost all of our infrastructure is in the eastern zone at Amazon. During the one outage, we were obviously caught by surprise. We were lucky in that the particular parts of the eastern zone that were impacted didn't affect where a lot of our stuff was. One of the applications that was, I think that was actually part of our video infrastructure, we were able to very quickly spin up a new cluster, again, thanks to sort of Rightscale and how we sort of had things set up. We were able to set up a new application array out on the West Coast to sort of help bridge the gap. So, but we have a long way to go. It's sort of it's a problem that we'll be lucky to have. I think that we're sort of starting to think about some of those sorts of things as opposed to just getting to those first 3 or 4 nines.
2 more questions.
Well, that killed the party. All right, go on. Well, thank you very much.